Hello, and welcome to MindFuel's webinar on project-based learning, climate change, and ecosystems. Today, we will be sharing how to initiate a PBL experience in your classroom. We would like to take a moment to thank Promoscience Science Literacy Week for the funding to make this webinar possible. To introduce ourselves, my name is Danielle Ings, and I'm an education specialist at MindFuel.
And my name is Karen Sandhu, also an education specialist here at MindFuel.
Thank you for joining us today, and we hope you find this webinar insightful.
So we're going to start today's session with a comparison between what true project-based learning looks like in the classroom compared to a traditional project. With a traditional project, the teacher will essentially teach the students all of the concepts of the unit and then end the unit with a summative project where the students are asked to apply or show their understanding of the concepts they've already learned. So the teaching happens before the project. Whereas a project-based learning experience, on the other hand, is introduced very early on in a unit through an overarching problem statement or question that students will investigate. And through this investigation, they will uncover information and learn those specific outcomes for the unit as they're working through the project. For a traditional project, the criteria, deliverables, and rubric are typically set by the teacher, whereas in project-based learning, students should have the flexibility to choose the issue or challenge that is meaningful and of interest to them, and then design a solution around that. So in PBL, there's a big emphasis on student choice and voice. In terms of assessment, project-based learning includes a lot of formative assessment embedded throughout it. And this is not only coming from the teacher, but also from peers, as well as students themselves. So time for reflection and modification based on self-assessments, peer assessments, and formative assessment from the teacher are necessary in project-based learning. Project-based learning is also focused around a real-world issue or problem, which helps especially those disengaged students in the classroom. So there should always be context behind the project the students are working on, and that always isn't the case for traditional projects. Finally, a big difference between the two types of projects is that of the teacher's role. In project-based learning, the teacher really moves to be a facilitator versus the direct instructor. And so that means guiding students, asking them questions, taking a step back, and oftentimes learning alongside the students as well. And this ends up really building good relationships between the teacher and the student and builds a positive classroom culture. So, what are some of the reasons we should implement project-based learning in the classroom? Well, there are many. We talked a little bit about increasing engagement, but one of the most beneficial outcomes of facilitating a project-based learning experience in your classroom is student development of lifelong skills that they can take outside of the classroom into their job or future careers. And these are sometimes known as competencies or 21st century skills. As you can see on the slide here, you'll see that through project-based learning, students should essentially be relying on and using every single one of these skills as they're working through a project. They'll be required to problem solve and use critical thinking skills throughout the project, not only in the beginning where they're analyzing the problem and ideating solutions, but in the middle when they're testing, interpreting those test results, and having to redesign. Also, towards the end when they're presenting and receiving feedback from a real audience. A little point on managing information. The information students are working with in a project-based learning experience is real-world information, so it's messier. It's not pre-selected or perfect data sets provided from a textbook or worksheet. Students will have to effectively manage this information in order to make sense of it and then apply it to their projects. Students will also have to rely heavily on their communication and collaboration skills, since they'll be working in teams to complete their project. That includes identifying different team member strengths and relying on those strengths, and communicating to meet deadlines. Finally, as mentioned before, since project-based learning is very real-world focused, with students investigating a real issue or problem that affects their local or global communities, through this investigation, they will be working on their global citizenship, as well as their personal growth and well-being. So, what's an example of what project-based learning could look like? On this slide, you'll see a photograph of a school garden. So this was a project that I worked on with my engineering students, and it was initiated simply through a conversation I had with the gardening teacher at our school. From her, I found out that she had a student in her class who was on a wheelchair and wasn't able to access the school garden. And so she had to sit on the side and just watch as her peers were able to actually do the work, and unfortunately she wasn't able to participate. So that sparked an idea, and I brought this real-world challenge back to my engineering students and posed it to them to come up with and design a solution for this student so she could participate more actively in her gardening class. So my students had to go out to the site, you can see them there in the picture, take photos, measurements, and really use this real-world data in developing a tangible solution. And that included forecasting costs and material, designing their solution using computer-aided design, and finally, for their presentation, I invited the assistant principal, the gardening teacher, and the student in question to make it that real-world kind of authentic experience for the students. So the stakes were higher. It wasn't a pen and paper theoretical type of project that they were working on. So this example also illustrates that project-based learning allows for opportunities to collaborate with other colleagues on your campus, and it also lends itself to a nice interdisciplinary approach in teaching.
To touch on a few more examples, the Geekstarter program emphasizes real-world connection. Geekstarter teams range in age from high school to collegiate and work on projects more focused on global issues. For example, finding a substitute for insulin or creating technology to eliminate a parasite affecting production of honey in beehives. In the CTF Accelerator program for grades 5 to 9, youth have the ability to create a variety of projects connected to the real world that tie to their career and technology studies curriculum, as well as an interdisciplinary learning outcomes. For example, one project involved creating and coding a math game to help younger students learn multiplication, as you can see in the picture on the slide. And for CTF construction curriculum, to build a wheelchair that could function better when playing soccer. For more information on these specific programs, please visit geekstarter.ca. So let's talk about common barriers of project-based learning for a bit. The following responses on the slide were taken from a pool of teachers and reflect the question of what barriers are associated when thinking about implementing PBL in the classroom. As you can see, a variety of responses were provided. However, I wanted to highlight a few that were mentioned a number of times, those being the ones starred on the slide. As you can see, there was a need for supporting resources. Another barrier was lack of time for planning, or how to ensure learning outcomes are being met. And finally, another one that came up common was how to assess the students' learning. These barriers are very common concerns for teachers wanting to implement project-based learning, and hopefully through this webinar and the ones to follow in the series, you will feel a little more comfortable and at ease in being able to tackle some of these barriers. On this slide, there's an overview of MindFuel's approach to PBL. We tie in elements of design thinking and use that to fuel projects. You can see we have highlighted what teacher prep is needed, and then through each stage, what key learnings are happening. In today's webinar, we will be spending time on the preliminary steps necessary to prepare for a PBL. To explore our approach a bit further, You will notice in the preparation stage that the teacher will select the curriculum connections and use that along with the UN Sustainable Development Goals to develop the driving question. It is also their task to gather initial primary resources, make preliminary connections to community members surrounding the driving question, and select an entry event for the students to be introduced to the problem space. We will explore this in just a bit. Moving into the empathize stage, teachers are introducing and engaging the students in the driving question of the projects. They're making that initial connection, and students are exploring the problem space, investigating those connections. In the define stage, the role of the teacher is simply to help provide initial outlets for resources and make initial connections to the community for the students. Students then further explore the problem space and issues surrounding it by conversating with community surrounding the challenge to better help gain information. In the ideate stage, the teacher simply is guiding the students, providing questions to further encourage student exploration. They are reflecting on student needs and making decisions based on that. Students are analyzing the research and issues they have discovered and using this information to brainstorm solutions and narrow those down to create the specific project goals. Next comes the prototype stage, where the role of the teacher is to provide materials for the students when needed. The student at this point is planning and developing out their particular project solution and creating prototypes of various elements. Then comes the test stage, in which teachers are facilitating and guiding students in the areas of need while the students are sharing their solutions in order to gain feedback and apply it to bettering their project. This whole process is iterative, meaning that students will be jumping into the different stages at various times repetitively as they continue to develop out their project further and further. Finally, at the end of the project timeline, students will present their projects in various forms to an authentic audience. It's important to note that at each stage, assessment and community connections are happening. And overall, you can see that PBL provides authenticity in learning, connection with community and subject matter experts, student voice and choice, reflection opportunities through various stages, iteration, and it really allows students to lead their own learning and discovery, and teachers acting as a guide. So, the first step to implement PBL and part of the preparation stage for teachers is to start with the curriculum. Starting with the learning outcomes gives the student projects a focus area and helps break down the barrier we discussed previously of ensuring students were gaining content knowledge. This example shown on the slide is from Alberta's Grade 8 unit, Fresh and Saltwater Systems. This unit covers knowledge such as identifying the significance of water supply and quality, its distribution of water locally and globally, linkages between landforms, water, and climate, factors affecting species in aquatic environments, and human impacts on aquatic systems and technology. To start a PBL in your class, you will want to pick a unit of study to focus on. At this time, feel free to pause and connect to your own curriculum tie-ins.
One approach to ensure the tie-in to curriculum as you're building out your PBL is to reframe those general learner outcomes as questions. As you can see, we've done that here for the 4 general learner outcomes related to this unit. So let's just look at one as an example. The second general learner outcome: investigate and interpret linkages among landforms, water, and climate. We've now rephrased that as a question. What relationships exist between landforms, water, and climate? Or analyze factors affecting productivity and species distribution in marine and freshwater environments. Instead, what factors affect the productivity and distribution of living things, found in fresh and saltwater environments. So this process allows us to more easily digest what those learner outcomes are for ourselves and for our students as well. Right now, we welcome you to pause the video and reframe one or more of the general learner outcomes for your selected unit. Now comes the time to frame your curriculum around that real-world problem or issue, just like we've been talking about. A great way to do this is by using the United Nations Sustainable Development Goals at the start of planning your PBL unit. You can see we've provided a link on the screen. Another way to access this is to simply Google UN Sustainable Development Goals. The UN SDGs, as we like to call them, are an urgent call for action by all countries, both developed and developing, and were created in 2015 and came into force at the start of 2016. These serve as a good starting point for project-based learning planning, since they are real-world goals and create a sense of urgency and authenticity to the project. As you're looking at the screen, you can see that the topic areas are broad and all-encompassing enough that almost any unit or subject area can be tied to them to put the project-based learning experience in a real-world perspective. For example, sustainable cities and communities can apply equally to a social studies unit as it does to a science or math unit. Once you go through the entire planning process, you'll find that you can attach your curriculum topics to one or more of these sustainable development goals. We invite you to navigate to this website and read the summaries on a few of these goals to get a better understanding of them, as we're going to be using them in the next step.
Now let's work on developing a problem space. A problem space is a focused area for students to explore further to identify specific issues that they will then narrow down to one and develop a solution for. An easy way to create a problem space is to combine the question you created from the learning outcome and tie it in with an SDG that is appropriate. It's important to note that there can be various SDGs that match one learning outcome. By rephrasing the question from the perspective of the applicable UN SDG, students have a focused area to investigate and research. It's also important to remember that when reframing the curriculum question to the problem space, the question should be worded as an actionable goal, including elements of both curriculum and SDG. Again, this formulates the problem space in which the projects will focus in. From this unit, we have shown an example of 4 different problem spaces. To dig a little deeper, let's look at the highlighted problem space. We took our learning outcome question of what relationships exist between landforms, water, and climate, and combined it with the SDG climate action. This naturally fit well to us and provided a lens we were wanting to create for our students. Combining these 2 elements together gave us a problem space of what can we discover about the relationship between landforms, water, and climate to address the impacts of climate change. As you can see, the problem space is not a question that has a simple answer. It has a need for students to spend time investigating and researching the various elements. Take some time to explore which SDGs would match with your selected learning outcomes and combine them to create various problem spaces for your unit. Now let's look at the empathize stage. In this stage, you are introducing the selected problem space to your students through an engaging hook activity. This entry event can be anything from a picture or video to a simulation or phenomena demonstration. It can also be a guest speaker who can share something relevant to the problem space, or anything to engage and hook your students. This is their first glimpse into the problem space, so you want to really kick it off with a lot of enthusiasm and spark their interest. At this point, this is the last of the pre-work that is needed by the teacher. From now on, the role of the teacher is to reflect on each meeting and where students are in the process in their project, and provide necessary resources, guidance, and teachings as directed by the student needs. A simple example has been provided from Giphy.com, in which the decrease and melting of polar ice caps over time is depicted. This is a very simple yet powerful entry event that fuels curiosity and further exploration of why this might be happening. Some next steps for your students would be to further investigate the problem space by connecting with community, accessing resources, and conducting research to identify various issues within that problem space. For example, an issue that came up from our example problem space is melting of the Greenland ice sheet that is causing extreme weather in eastern Canada. And another issue is the coastal communities being affected by rising sea levels. Then, they are tasked with narrowing down the issues they found. Some methods used are curriculum checklists to again ensure that outcomes are being addressed, researching problem space and issues further, connecting with community, and then selecting an issue or challenge to focus on. Once they have selected one issue to focus on from all their research, they can begin developing, investigating, and working on a solution as their project. In upcoming webinars, we will dig deeper into the following stages of the project, but here is a brief overview of each. In the define stage, it's important to reinforce curriculum needs, and in order to develop a solution, the student needs to identify the root problem. Then, in the ideate stage, students begin to brainstorm possible solutions and reframe the problem by continuing to analyze the solutions through research and community outreach. In the prototype and testing stages, students are beginning to make elements of their project tangible and see how it works with their audience it is associated with. It is important to note that a prototype does not necessarily have to be a mini version or final product. The action itself is used to enforce the iterative process that then helps to develop a stronger project and solution. Finally, after students have partaken in multiple iterations of these stages and the project timeframe has come to a close, it is always helpful to have a presentation of the project to allow students to showcase their work and share it with an authentic audience to gain feedback and acknowledgement. As you can see, there's a lot to cover in this process, and we look forward to having you join us in our follow-up series on project-based learning stages. Project-based learning truly is a rewarding and instrumental approach to teaching that allows your students to take ownership in their learning, ties in valuable skills, and meets the needs of all your learners. If you can successfully create a PBL mindset and environment in your classroom, you will be amazed at the benefits it will bring to you and your students. So we'd like to thank you for taking the time to watch today's webinar on project-based learning, and again extend a special thanks to NSERC and Promoscience Literacy Week for providing the grant. If you have any questions, please feel free to reach out to us via email, and we look forward to having you join us in the next webinar for this series.